Fine. So pipeline parallelism means it will pump the data from one stage to the next stage. Data is keep on pumping from one stage to another stage till the last record extracted from source. Partition parallelism, using this partition parallelism, the same job will effectively be run simultaneously with several processing, and it will distribute the data into multiple nodes. So that is the difference between pipeline parallelism and partition parallelism. Okay. So what is a configuration file? What is the use of configuration file? This is also one of the common interview question.
Configuration file use చేసుకుని nodes increase చేసుకోవచ్చు సార్.
So by using the configuration file, we can allocate the number of nodes in a particular job. Right? The purpose
Yes.
the purpose of configuration file is describes every processing node that InfoSphere data stage will use to run your application. When you are running a parallel job, the InfoSphere data stage first reads the data from configuration file and determine the available system or resource. For example, you have created a configuration with 2 nodes. So the data will be distributed in 2 nodes. So here, then how many number of node allocations that has to be set up in the configuration file. Okay. And the next question is, what are the important components in the configuration file? What are the important number of nodes allocation, node information, how many nodes we are using in this job level, project level. So both will be created. So what is meant by job level and what is meant by project level? So can any one of you answer this question? What is meant by job level and project level?
Job level will run within that job. That means by the stream. Project level means will run the entire stream. I mean entire project.
Entire project. Yeah, correct. So here what happens at project level? Project level settings are there will be default settings. If you apply default settings for each job, what are the nodes that you declare default? 4 nodes or 2 nodes. So it will take into consideration. And specifically for example, one of my scenario, I need to extract the data 4 million records and above. So in that case, I need 4 nodes. So project level settings are defined as 2 nodes. So if you don't define anything, system will consider default setting, that is 2 nodes. For a specific job, when we receive the data in heavy volume like 4 millions and above, in that scenario, what happens is we are reading 4 nodes, right? Then it will distribute the data into 4 nodes. Okay. And the next information we have is pool information. Pool information is nothing but which node is running more. I mean, which node the node allocation, the record is available in which node and all. And fast name. Fast name is nothing but server details, host details of the data stage. Okay. And resource disk. So here we'll be creating data sets. So what is the use of data sets? To store the data permanently for intermediate data processing stage. Okay. So just a minute, please. And what is the scratch disk? The purpose of scratch disk is to store the data in a temporary purpose. Okay, so sometimes it will be empty automatically. If it is not getting empty, then you have to clean it manually. Okay. So what is the partition that is being used to remove the duplicates?
Yes.
Okay. So this is also one of the common interview question. Without remove duplicate stage, what are the ways that we can remove duplicates? Okay. So what are the ways that we can remove duplicates here? So by using remove duplicate stage, okay, by using hash partition technique, we can remove the duplicates. Okay. By using
We have a unique
Yes, yes, correct, correct.
Unique option sort, I guess, right?
Yes. Unique కూడా పెట్టుకోవచ్చు option.
Yeah, so here we have a unique option. If you use hash partition, what happens? And you have to consider the sort option, and you need to click on unique. So when you click on unique, what happens? Data will be, duplicates will be eliminated on the based on the key columns that you selected. Okay, so that is hash by partitioning technique can remove the duplicates. Another method of for removing the duplicates is remove duplicate stage. So here you have to enter the key columns. Okay, and the next option is by using the sort stage, allow duplicates option. You need to set it to false. If you set it to true, the duplicates will enter into the target. If you set it to false, the duplicates will be eliminated here. Okay. What are the ways that we can sort the data? How many methods we can sort the data? By using sort stage, we can sort the data. By using partitioning technique. So here you can use like hash partition, round robin, okay, and sorted merge data collector, which is in the target. Okay. And here, and the another question is, what is the difference between CDIC and ASCII sorting order in DataStage? So this is what is the difference here? Okay. Yeah, please go ahead. What is the difference? So there are sorting techniques, sorting algorithm in DataStage. One is ASCII as a default one. If you don't define anything, it will consider ASCII. And if you define EBCDIC option as true, then what happens here? Okay. So for example, let's consider the ASCII sort order. Okay. So ASCII sort order, notepad. ASCII sort order. So what is meant by ASCII sort order here? First, numerical data will sort first. Data. Next one is alpha numeric. Alpha data and alphabets. Alpha. AL. PH. Alpha data. So this is ASCII sort order. So if you don't define anything in the sort order, so it will consider this. For example, EBCDIC order. How this happens? When we need to set this true in sort stage, okay, or remove duplicate stage, or normalized it is available in sort stage. So when you set this in true, okay, first what happens? It will sort the data for alphabets, then alpha numbers, and the third one is numerical values last. Okay. This is the main difference. Next question. What is the differences between filter stage and switch stage? What is the difference, guys? So filter is a multi-columns filter. Okay. So whereas switch is a single column filter. So coming to the input links, both has one input link, and for filter, It has unlimited output links, one reject link, which is optional. And filter is a multi-column filters. What is meant by multi-column? Multi-columns filter. What do you mean by multi-column? What do you mean by multi-column? Please speak out. Ashok, what is meant by multi-column?
We can filter the data number of key columns.
Number
But
of.
in a switch, we have to only one column only we have to.
Okay, multi-columns means more than one column, right? So we can define more than one column. So, okay, for example, here I need employee so-and-so department. So-and-so department like department number is equals to 10 and I need to apply the condition. In the same department, I need manager data. Okay, so this is my requirement. Okay, department is 10, department is and so you can apply R. So I need manager's data along with department number 10. Okay, so if you are giving multiple column filter means giving more than one column condition in the where class. So here in filter stage we have where class. Got it?
No.
Okay, so here we'll be giving like this.
Where class we are using and R only. Other than that, we have to use any other under R.
And R. And or you can use in also. In you have to open brackets. That also we can give. How we will write in SQL, the same way you can write here. But switch is only single column filter. Switch is single column filter. Okay. So we have to write a case statement. We have to write case statement. Write case statement. Okay. So department number 10 should go to one output link. 20 should go to another output link. Okay, like that. So here by using case statement, so we have to choose the column on which one you are applying a case statement. So we have to, and you have to provide the values. Case is equal to so and so, like that. Okay. So that is a single column filter. Switch is a single column filter. And another important, powerful interview question is default. Any interview they will ask this question. What is the differences between lookup, join, and merge? Okay. So here for easy format, what I did was like I have segregated into 4 categories. Okay, different types of different types: input link, output link, reject link, sort methodologies, data filters. Okay, and data handle. So let and partitions used. So now let's discuss one by one. Okay, so here input links. Let's come to the input links. How many input links are there for join stage?
N to 1. Number of inputs and 1 or.
Yes, n to 1, correct. Join stage n to 1. N is to 1. So n means input link here. 1 means, so my left side is input, right side is output. N input links means in that n input links will be considered as 1 left link and 1 right link. For join stage, 1 left link and one right link. One left link and one right link.
I mean, very first link you can call it as left link, sir. Very first link, and second link you can call right link. Other than these two links, you can call as intermediate link. Right?
Yes. First link is left link. Second links are second link you can consider as right link, and other links we can consider as n number of intermediate links. Okay. So this is for join. So now let's see for lookup. So what is the lookup? How many input links are there? Lookup, one primary input link and n number of reference links as a input. One primary mainstream link as a input and unlimited number of reference links. Okay. So now let's consider merge stage. So merge stage has single primary master link, and updated links are unlimited. And updated links are unlimited over here. Okay. So now let's consider here output. So giant stage has only one output link. As you said, n is to 1. And similarly, lookup has one output link and one reject link.
Sir, for my concern,
Okay.
yes, sir. Could you take one square box and give the in a whiteboard? It is easy to understand the students, sir. Rather than telling, is also fine. Take one whiteboard, sir. Give one square box. Before that, we have give one input, number of inference links, and one output. Then the students will be easily understand. As per my point of view.
Okay. So for that, what we can do? Mapping. Mind map. I don't have a map software here. So next time I will try to install mind map.
Whiteboard, if you share the screen, whiteboard also is there. There also we have to give like that.
Oh, okay. Yeah. Good. Okay. Just give me a minute. Okay, so here. Okay. Yeah. So this is join stage. Okay, so I will join stage. JN. Okay, so join stage. So here input links N. Okay. So this is another input link. So let's do one thing. So this is left link. And right link. Okay. So in the middle we have n number of intermediate links. This is n number. Okay. So let's make a connectivity here. And one OP. So the next time I will open DataStage here, so that we don't have any problem. So one OP means output link. Okay, guys, are you able to follow? I think we have discussed in
Yes.
the sessions, right?
Yes.
DSR doesn't link. DSR doesn't support it.
Reject DSR, DR doesn't, DSR doesn't support reject. Okay. So remember one thing, giant stage does not Join stage does not have reject link. Okay. So now let's go to the Word document. So let me close this. And reject link, not there. Okay. So in lookup, so let's see the lookup here. Okay. So let me delete this diagram. Yeah. So lookup has one reject link. Only one reject link. Okay. So what about merge stage? How many number of update links are there? That many rejects will be there. If you see the merge stage, okay, so I will show you in IBM portal this thing. Merge stage in data stage. So here you can see. So here I have 3 update links: update 1, update 2, and update 3. How many number of update links are there? That many rejects will be there. Okay. So here how you can say reject links? So input links -1. So that will be the reject links. For example, I have 4 input links. Okay. So reject links will be 3 input links for the merge stage. Okay. So in that how many rejects will be there? So 4 minus 1. Okay. Formula is input links minus 1. 4 minus 1. So that will be 3. 4 minus 1, that will be 3. Okay. So here, so that many rejects will be there. 4 minus 1. How many number of input links are there? That has to be -1. So that gives the reject links. Guys, are you able to follow? In the merge stage.
Yes, sir.
Okay. So there is no complexity here to understand the things. Okay. So then now let's move on to another this thing. What is that another? Sort. Inbuilt sort. Join stage has inbuilt sort. Okay. No option for data sort. Lookup has no option to sort the data. So default option won't be there. You have to sort by using partition technique. Remember this. For lookup stage, if you want to perform the sort, what you need to do is you need to use partition technique. Okay. And sort option will be available. So in the merge stage, here we have the option sort option where data will be sorted here. Okay. And can we filter the data in join stage? Join and merge stage, we cannot filter the data. But in lookup stage, we can filter the data from the mainstream link. So I am receiving heavy volume of data. I don't need all the data. And I need to do the analysis on few conditional data. Then you can apply the filter constraint, data constraint, data logic constraint. Okay. So you have to apply the filter condition in the lookup. Okay. So data handles. What kind of data it will handles? Join stage handles high volume of data. Okay. So whether lookup stage will handle high volume of data? Yes. it can handle high volume of data only at mainstream link. Reference link will handle small volume of data. Okay, so even reference links also can handle high volume of data, but you need to use sparse lookup. So whenever we receive the data from databases, so we can use the Spark lookup. In that scenario, we will be using Spark lookup to handle the high volume of data. So default is, if you use normal lookup, default is we have to use less volume of data in the reference. Okay, it cannot handle heavy volume of data, especially in a lookup reference link. Okay, handle large volume of data. The merge stage also can handle. How the join stage will handle same way, it will handle the large volume, heavy volume of data, huge volume of data. Okay. So and partitions used. What is the partitions used? So partition join stage and merge stage we use hash partition technique. Okay. And for lookup mainstream link, you will use same partition, and reference partition here we can use enter. Reference link we can use enter. Okay. So these are the key differences, guys. Okay, so between lookup, join, and merge, you should remember all these things. And even if you face the same question in interview, you should be able to answer this. Okay, so I'll be sharing this document with you. You can go through this, and you can remember and understand the. So try to remember and understand the concepts first. Okay. So the next interview question is, any questions here before I move to the next interview question?
Sir,
Sir,
No,
in
why
yes,
merge
sir.
stage,
particularly? Okay, go on.
in merge stage, we can use only hash partition, or else we can use any partition technique. So I have a doubt on that.
Yes, we can use hash.
Only hash, we can't use another like
If
NAT and
you can use, but
okay,
default system will supports auto. Okay.
okay.
So to improve the performance,
Okay.
we can use
So
hash.
in here also mainstream is there, no? Same partition only we can use, or else we can use here also entire we can use it, sir, in lookup stage.
Yeah, mainstream link you can use same, and the entire thing you can reference link you can use entire.
No, we can't give there also entire partition in mainstream also, no?
Mainstream only we have to use
Same.
no, mainstream we have to use same. Entire you have to use reference you have to use entire. We cannot
Okay,
use
okay.
entire in the mainstream. What happens is the duplicate will be coming
Okay,
from the source. So
okay.
sometimes the interviewer will come. Can we use entire
Uh,
partition in the mainstream link?
Okay, no.
We can use, but duplicates
Okay.
will come. We have to answer
Duplicates
like,
will come.
yeah, duplicates will come. We
Okay.
have to answer that, answer him like that.
Okay,
So
okay.
to process the data, what you need to do? You need to remove the duplicates. So to
Okay.
avoid all these things, you can use same partition.
Same partition. Okay. Okay, thank you,
Okay.
sir.
Yeah,
Okay.
great. And Akam, you are saying something. Please go ahead.
Yeah. My question was also similar to her question only. Why only hash partition? Why not another like round robin, which is optimal one? So why not round robin like that of
No,
only hash? Why we are using it?
so if you use hash in join and merge, so performance of the job will be improved.
Improved. Okay. So over the other partition types.
Yes. Okay.
Sir, one more thing. In the sparse lookup, the sparse lookup will support reject link, sir.
Sparse lookup will support.
I faced this question in an interview, I guess.
Yeah, obviously it will support the reject link. Yes. So it doesn't matter whether if you're using Spark lookup or normal lookup, the reject link always will be there. Okay. So tomorrow we'll test that. Okay, in the class.
Okay, sir.